Hello, friends! NASA launched the world's largest and most potent space telescope. The James Webb Space Telescope is its name. You can sort of travel through time with this. Although it is impossible to travel back in time, you can get a sense of the past with this. This telescope can literally view the history of millions and billions of years. And I'm not just referring to the last 5 or 6 years. 13 billion years to be exact. The Big Bang occurred 13.8 billion years ago, marking the beginning of the universe. Additionally, this telescope can see back up to 13 billion years, roughly 0.7 billion years following the creation of the universe. However, how is that possible? Come, in today's video, let's understand this phenomenon.
Liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
Nature has this way of being even more creative than we are. So we have always been surprised by what we see in the sky. That's why building a telescope has always been interesting.
Obligation to learn about space, but it would be foolish and short-sighted not to do so.
The primary purpose of this telescope's design is to detect infrared light, which makes it unique. Using a standard telescope, you can observe the visible light wavelengths in the sky, the light that is visible to the unaided eye. Do you recall your schoolwork on the electromagnetic spectrum? There are many different types of electromagnetic waves. It contains radio waves, microwaves, ultraviolet rays, X-rays, and a tiny amount of visible light, the light that is visible to the unaided eye. The standard telescopes that are available at any store only allow you to view the visible light's wavelength. Red is the color with the largest wavelength in the visible light spectrum, which ranges from blue to red. Furthermore, as you are aware, electromagnetic waves can more easily penetrate any obstruction or object when their wavelength is larger. Similar to radio waves, the radio you tune into. Radio waves can have wavelengths longer than kilometers. As a result, you can even hear radio waves traveling through buildings. Infrared wavelengths are larger than red wavelengths. However, infrared is invisible to the human eye. This image illustrates the benefit of using a telescope to view infrared. The Hubble Space Telescope captured the image on the left, the strongest space telescope we have ever had. The space dust is visible in it. Additionally, you can observe the formation of gas clouds. However, we will be able to see what lies behind this because infrared wavelengths can penetrate clouds and dust. We envision what we could see with the James Webb Telescope in the image on the right. In essence, we will receive a higher quality, high-definition image. Infrared essentially means below red. The Latin word infra means below. Infrared then literally translates to below red, since its frequency is lower than red's. Additionally, wavelength and frequency have an inverse relationship. You will remember this. Infrared waves are released by anything that radiates heat. Infrared waves are released by the sun, fire, animals, and humans. For this reason, soldiers frequently wear night goggles, which essentially detect infrared. This is the view you get through the night vision goggles. Infrared cameras are used to record it. The telescope will be able to record and view the infrared waves because it will be observing planets, stars, and star-forming galaxies, all of which emit heat. The other benefit of infrared is that when a telescope observes stars that are billions of kilometers away from us, the light from those stars has traveled so far that by the time it reaches the telescope, and since the universe is known to be expanding slowly, the light's wavelength has been stretched. The wavelength lengthens. The redshift is the name given to this phenomenon, that the light's wavelength has slightly expanded and moved in the direction of red. A telescope's capacity to capture light increases with the size of its mirror. Additionally, the image's resolution will be significantly higher. This is the reason why increasingly sophisticated telescopes are being built with larger mirrors. This was the size of the Hubble Space Telescope's mirror, and next to it is the James Webb Space Telescope's mirror. 24-karat gold has been used to plate the entire mirror, because red light is best reflected by gold. I mentioned that infrared waves are released by anything that radiates heat. The telescope will also radiate some heat when it first starts up. The telescope itself will emit some infrared waves. It will disrupt the waves originating from the galaxies, making it impossible for us to obtain high-quality images. This James Webb Telescope will only function at extremely cold temperatures, minus 223 degrees Celsius, in order to prevent this. For it to function, the temperature must be extremely low. The temperature has never dropped below minus 89 degrees Celsius on Earth. So how did they manage to keep this telescope so cold? Doing it in space is feasible. It is feasible because, absent sunlight, space is extremely cold. If the room is exposed to sunlight, the temperature will rise quickly, just like on the moon. The moon's lack of atmosphere can cause temperatures to drop as low as minus 170 degrees Celsius. However, as soon as the sun appears, the temperature reaches 120 degrees Celsius. This telescope has a lot of issues. This telescope would become problematic as soon as sunlight hit it because everything would heat up quickly. Thus, the sun had to be stopped. This James Webb Telescope has a sun shield installed to prevent this issue. This sun shield is as large as a tennis court and has a kite-like shape, in order to keep the telescope safe from the sun. Captain, a very special substance, has been used for this. To find the best material to block the sun and keep the telescope cool, a number of materials were tested. Captain was later found to have been manufactured. Each of the 5 layers of Captain that make up this sun shield is thinner than a human hair. Every layer has a vacuum gap between it, in order for it to be more effective. In addition, each layer is coated with aluminum. Additionally, a layer of doped silicon covers the 2 layers nearest to the sun. Unlike the Hubble Space Telescope, this space telescope is not being placed close to Earth. Hubble orbits the Earth and is located near it. However, this will be set up 1.5 million kilometers from the planet, at what is referred to as the L2 point. Lagrange point is represented by L. This point will be on the opposite side of the sun because, as is evident, blocking as much of the sun's heat and light as possible is crucial for this telescope's optimal operation. Additionally, the L2 point is unique since it continues to revolve with the Earth. Thus, during the revolution, the sun will remain hidden. Take a look at its orbit. The sun will remain obscured by the Earth's shadow. It's comparable to how sunlight obscures vision when you're looking at something directly at the sun. It is analogous to covering the sun with your hand. You can also see more clearly. The telescope is no different. According to NASA, the process of developing and launching it is so intricate that they have identified over 300 possible issues. The project as a whole would be doomed if any of the more than 300 single points of failure materialize. For this project, $10 billion has been spent. Because of the size of this sum, NASA had to divert funds from other research projects in order to fund this one. The European Space Agency and the Canadian Space Agency are also involved in this, in addition to NASA. Scientists are hopeful that this will allow them to investigate how stars and galaxies formed following the Big Bang. You can look back 13 billion years with this telescope, as I mentioned. Only a billion years after the Big Bang, the Hubble Space Telescope was able to observe, approximately 12.8 billion years ago then. But 0.3 billion years after the Big Bang, the James Webb Telescope can see, as this diagram illustrates, when the stars initially started to form. How is it possible to look into the past, one might wonder? It has a very straightforward answer. It takes a while for the light to cover the distance. Additionally, a lot of time would have passed by the time the light made it from one location to the other, particularly when it comes to such vast distances. It takes about 8 minutes for light from the sun to reach Earth. It implies that if the sun were to abruptly disappear, for instance, it would take 8 minutes for people on Earth to notice the disappearance. You could say that when we see the sun, we are, in a sense, looking 8 minutes into the past. Apply this reasoning on a larger scale as well. The stars and galaxies that are millions of light years away from us are actually visible to us, as they were millions of light years ago when we view them through a telescope or from Earth. Because of the size of the universe, stars that are 13 billion light years away from us would have been gone for 13 billion years by the time their light reached Earth, meaning that what we see today is the result of events that occurred 13 billion years ago. We can get a glimpse of history in this way. Using this reasoning, it is also theoretically possible that we could teleport to a planet 100 million light years from Earth if we traveled that far. And if we construct a very strong telescope on that planet, we will be able to observe the Earth as it was 100 million years ago. Dinosaurs will be on display. The real issue with this, though, is that it will take a lot longer to get to the other planet than the years we can look back on when we get there and look back at Earth. Therefore, we will be able to witness history unfolding on Earth if teleportation becomes feasible, and would have the ability to travel through time. The discovery of new planets by the James Webb Telescope will also be fascinating to observe. Can it locate a planet that resembles Earth? The place where life might exist. We'll find out in time. I'm hoping you enjoy this video. Let's get together in the upcoming video. Thank you so much, dear friends.